So what I'll do is this will be an interactive session. I'll just ask questions and just expect, that somebody will pipe up. One of the misconceptions about artificial intelligence is that it is basically a repository of facts. Part of what you'll see in those videos that I shared with you is that the transformer architecture was built by Google back in 2017. So the common nomenclature that you hear, generative pre-trained transformer or GPT, really has become the heart of that. One of the misconceptions that there often is about large language models is this idea that it's facts, when in reality, what it is it's a text prediction machine. It takes a look at the information that is around it in order to figure out what exactly it needs to pay attention to. So the information goes into it, it gets transformed, and then the goal is that some content gets generated from that transformer. So most of you are familiar with like ChatGPT or Gemini in order to get a response back. And so it's really good at generating that text and predicting the next word. But that's one of the misconceptions that I think leads people to not quite get out of the system what they think they should be getting, and what they think they should be getting, in part because there's a fundamental misunderstanding of what a GPT actually is. Now, before we dive into the details, what I wanted to do is I wanted to talk about, well, why exactly does all this matter? So there's about 14, so obviously the market is shifting, and there are a couple of places where we're seeing it move. One is in junior knowledge work positions, whether that's product manager, whether that's a developer, whether that's an analyst. Those jobs effectively are being put on hold, at least because there's a belief that these knowledge work organizations just aren't going to need as many people. Now, one of the things that you'll see in this slide in the lower right-hand side, it says 72% of CHROs, which stands for Chief HR Officers, expect AI to eliminate roles by 2026. So the HR department heads recognize that there's going to be less demand for people, or at least that's what they anticipate. And so one of the things that you may have heard recently is that Amazon, for example, just laid off 30,000 people. And some people are saying, well, that's because their jobs are being taken by AI. Well, that's part of the story, but Amazon is actually taking that $6 billion that they saved in salaries, and they're basically using it to build out AI-based data centers. So I would say in the near term, what we are seeing is that the salaries, especially among technology companies, are being shifted to these artificial intelligence build-outs. So there is a very strong belief in the market and among organizations that, one, they're freezing hiring. Second of all, they may actually lay some people off, and who they tend to lay off are people that don't have artificial intelligence skills. So what we're seeing is that more and more people, in order to be able to maintain their job, they are being asked to skill up on artificial intelligence so that they can be more effective in their positions. And so basically they can do more with less. So one of the challenges is, if AI really starts to displace people, the time to start building those skills is actually right now. It's not later. It's not when there's a glut of talent. It's not when a whole bunch of people get laid off, which tends to create a chain reaction of other people being laid off. The time to build those skills, like it's urgent, because by all metrics, that is the direction that AI development and capabilities is going one direction, and it is simply getting more and more intelligent all the time. So to give you an example of this, there's a company called Anthropic that just pushed out a new application, and they were able to develop it in 10 days. It was a small team of developers, but they were able to go from here's the idea, here's the set of requirements, to building it out and making it a reality. And now, granted, this was a beta project, but in 10 days. And I think that's probably what we're going to see on a similar trajectory, is that organizations who are into software are going to start developing more and more quickly. So regardless of what your job or role is, whether you're a consultant, whether you're a developer, whether you're a product person, whether you're in quality assurance, and even whether you're in project management, even if you're in project management, artificial intelligence has the ability to displace some of those skills. So Jill, I saw your note that you had read through the materials, and you still aren't quite sure what the objective is. The objective is to make sure that you have a foundational understanding of artificial intelligence, where it's going, and what its capabilities are. So hopefully that will get unfolded as we move forward. So let me just pause there for a minute on job shifts, and the skills that are anticipated to have artificial intelligence kind of erode people in those positions. What questions do folks have about the job market and where it's going?
So Jason, I can ask a question or add to that. So this is really imperative. I work for a really large health insurance company that's a national company, and we're going on a business trip to Las Vegas next week. And one of our focuses is being able to integrate AI and how that can adjust, make our jobs more efficient. What do we do with it? How do we utilize it on all levels, right? On C-level, also, out in the field and whatnot. So super relevant. And, we are actively having these conversations internally about how to make it relevant, efficient, and essentially being able to do more accurately.
Yeah. Thanks, Mikkel. Eric, I know you're in the security space. Is there conversations being had about how artificial intelligence, either one, increases the risk, or two, can help to protect organizations?
Yes and yes. In fact, there's with the company I work for, there is a large push on both fronts. One, how do we leverage AI to kind of what the previous person was talking about? How do we make ourselves more efficient? Find the most important things faster, so we can respond faster, and even use artificial intelligence in some of those response workflows. From an attacker perspective, but as well from the employee perspective, how much more can we do if we can, some of the repetitive tasks, because everybody's understaffed. So it's how do we do more with less? So we're not looking at it to replace jobs. We're actually looking at AI to help expand the areas that we can now look at, because we can free up some of those resources. So we are definitely looking at that as a very heavy push across all spectrums of everything we're doing in the company.
Excellent. Thank you for sharing that, Eric. So just to kind of follow up on that, as I mentioned before, it's the junior people that the job market is shrinking for at this point. So the example here is, architect versus bricklayer. Because the bricklaying, the software development, the analysis can be done more and more effectively by artificial intelligence, the value of the laying the brick, the market value of that is going down. The demand for it is going down. But the demand for architects is going up. People that are able to design systems, people that have good judgment about the usability of products, people that are reviewing code or validating that things are testing, people that have people skills, things like empathy and coordination and communication. All those skills are increasing in demand, and the expectation is that the market will continue to increase those salaries somewhat at the expense of the hiring of those junior analysts. So some of the initial labor and employment statistics actually show that this is no longer theoretical. I did some analysis the other day, and the estimate is that in 2025, approximately 125,000 jobs were eliminated across all industries, obviously primarily in white collar and knowledge type works. So that is where we're starting to see the pivot. Now, Jill, I think to go back to what you were saying before, just understanding the content, again, it's important to understand what a transformer is. And what it really is it's a next token prediction. Now, token, just think of that as either a word or a fraction of a word. And so we're feeding information in, it's trying to pay attention to what the entire context is, and it's trying to predict the next word or the token in the sequence. And it's got the ability to hold a really large context. So what we are seeing now is that models that are able to store up to 1 million, sometimes 2 million tokens effectively in its memory while it's doing this analysis. And part of the reason why that, so just to give you a sense of scale, that's like several, very long books worth of information that it can hold in its memory. Now, as a human, like I don't have the ability to hold that and to consider that in the context of trying to receive a question and provide an answer. So its ability to hold these large quantities of information in memory to appear to think about it or to generate a response it's really phenomenal. And it's a significant difference between humans and these large language models. Now, one of the things that I will say is that what these models aren't necessarily terribly good at is what we would traditionally think of as thinking. Like it does not, so let's say I need to develop an application or I need to create a spreadsheet to track something. I can give it like one sentence, but the output that I'm going to get of the large language model trying to meet that intent, I'm going to get highly variable outcomes from that. So it becomes important to be able to set that context, but a human has to do it. It has to know what the intent is. It has to know what the design is. It has to know what the features are. It has to know what the look and feel is. And so what we're seeing is that this upward movement of skills from tactical analytics, software development, test case execution, and we're seeing that moved up to more of a systems design and an architecture, again, because the detailed laying of the bricks is already being taken care of by the large language models, to the point that we have some of these technologists, Sam Altman, Dario Amodei from Anthropic, that are talking about in these organizations that 80 to 90% of the code is being written by the large language models and through artificial intelligence. So anyway, just another emphasis that because it can hold all this information in memory, because it can recognize patterns, it's the detailed administration, workflow, repetitive patterns that artificial intelligence is particularly good at those are the domains where they're starting to take over those types of activities. So what that does is that changes people's responsibility from doing the details to overseeing the details. So an example of that is I would put a prompt into a large language model, and then I would get a response back. And in that response back, I'm evaluating, did it give me what I wanted? Is the information that it provided to me, because I'm a domain expert, is that actually accurate? And if it is, then, I'll take that and maybe iterate on it. If it's incorrect, then I have to go back and make the corrections. But this pattern of setting the intent, setting the parameters, and letting the artificial intelligence do the work, and then evaluating the outcome is the new pattern that we are starting to see emerge in knowledge work. So pause for a minute. What questions? Yeah, Eric, you're raising your hand.
Yeah, just out of curiosity, with we're talking about the large language model and the language aspect.
Yes.
But where the crossover is, with even with ChatGPT, for example, you can use it for video and image creation, Google
Yes.
as well. Does it follow similar principles? And if so, and if not, how are those different? And if so, how does that apply as far as what is that doing for job markets now? Companies are utilizing it.
Yeah, that's a good question. There's one thing that I will say, and then another thing that may not necessarily be obvious. So the image generation and the video generation it's fundamentally a different type of a model. So typically, in technical terms, it's a diffusion model. If you ever see AI render an image like in real time, what you'll see is it's very gray and cloudy, and then slowly you start to see the color blotches emerge, and then you get to the detail. So what has happened is that model, which is typically a diffusion model, has been trained on a whole bunch of images, and somebody has literally said, this is like lots of times there's actually encoding on that, so they know this is a bird, this is a car, this is the sky, this is a cloud. And where we're starting to see an overlap between large language models and these image and video creation models is that what we're doing is that we're tying together the imagery to the text. And the models so the model will start to tie to the imagery, and it will make it so that you can type something out and it knows how to decode that into images. So technically it's a different model, but really there's also another training that's going on between the language models and between the images, so that when you type something in, it has to be trained very specifically on this. It has to be trained to know, okay, what exactly am I going to render? An example of this, so today I was creating a thumbnail for a course, and I had a headshot, I had a logo, I had the course name, and I had a color palette. So what I told it to do is I want the logo in the upper left-hand side. I want the course name on the left-hand side below the logo. I want the headshot over here on the right-hand side. And then these are the color codes, and I want it to match this particular palette. And it actually did a very good job of putting it together, but I kind of had to paint the picture for it. I had to give it the building blocks, and then I had to paint the picture for it of exactly how to assemble it. And it did a very good job of doing what I had asked it to do. So it's a type of artificial intelligence in that it is being trained, but it is working in tandem with these large language models on how to transform that text into the imagery.
Okay, thank you.
Yeah, you're welcome. I'll just pause for a second. Any other questions before I continue? Yeah. So one of the next things that I wanted to address, and this is talked about in the preparatory materials, is this idea of retrieval augmented generation. So I was talking with Kate and Igor earlier today about how these retrieval augmented generation systems work. And so so I'm going to give you a couple of examples to explain the process here. So if I just ask a large language model to give me an answer to a question, basically what it does is it uses that next word prediction in order to give me a response. Now, it may sound completely confident about the response that it's giving to me. Because basically what it does is it's, again, that next word prediction. And it uses those probabilities in that language model in what is called parametric knowledge or parametric data. So when you rely strictly on parametric data, you're very likely to end up with varying degrees of hallucinations. And that's one of the things that lots of people have really been concerned about with agents and with large language models, is this idea of the hallucination, where it just predicts the next word, but that doesn't mean that it's factually correct, or even that it makes sense, even though superficially it has the perception of making sense. So this is where, like, we want to get away from the hallucinations, and we want to narrow down the information or the response information to a much more confined set of information, say a book or a PDF or a document, or maybe information from a website. So with retrieval augmented generation, and if you watch the videos, I think it explains it incredibly well. And what I've shared with you are literally some of the best videos that I found about large language models. And it may take a couple of listens to actually be able to decode what it's talking about. So imagine rather than just sending a request to a large language model and getting a response back using that parametric information, what I want to do is I want to say, okay, look at this information. And I want you to tell me the parts of that information that mean the same thing or close to the same thing. And then once you find parts of that text, then I want you to take all that text. I want you to give it to a large language model to basically convert it into human understandable language. So if I've got a PDF, let's say there's 2 or 3 paragraphs that are relevant, I basically take those paragraphs, give it to the large language model, and then it gives me a response back in a human readable form with those pieces of text as what is called grounding, which basically says, I'm not going to just make stuff up. What I'm going to do is I'm just going to format that in a way that a human would understand and make sense. So this is one of the key ways that we prevent hallucinations, because we're not just relying on that parametric data from the large language model. We're actually grounding it in very specific pieces of information, and that largely reduces a lot of the hallucinations that come from the large language model. So I'm going to pause there. What questions do you have about retrieval augmented generation? Well, first of all, like, does this make sense? Does it make sense when you would need to use this or how it would be helpful?
Yes, it does.
Yeah. Right. So the final is the concept of fine-tuning a model. So let's say, for example, and one of the areas where this is getting a lot of attention is in the legal field, especially for people that aren't lawyers, they're not legal experts. So let's say that they want a draft of like a contract or a rental agreement. So one of the things that somebody who isn't legal, like they may go to a large language model and say, hey, I need a draft of this agreement. But they may not use the right words. So, but you want words that roughly mean the same, that have the same, what is called semantic meaning. So if I type into a large language model, I want this agreement. I'm not quite sure of the words, but I want to make sure that I understand the statutes. I want to make sure that I am financially protected. Let's say, for example, there is a fine-tuned model of legal statutes and legal agreements. So a fine-tuned model is basically, think of it as I take that large language model, but on top of that large language model and weighted more heavily than that language model is kind of another model that is tuned specifically for the legal space. And so I can generally get in the ballpark, but because it has been fine-tuned in that legal space, basically what you're doing is that you're programming in intuition. So you don't have to be perfect. You don't have to be perfectly precise. However, it intuitively understands better what you're trying to do because it has been tuned. So let's say I've got this legal database that I've fine-tuned for legalese. I'm not going to ask it questions about engineering. I'm not going to ask it questions about architecture, because what it's going to do is it's going to try to cast that in the context of legal, kind of that legal domain. So if you're going to fine tune a model to make sure that you're kind of tuning in that intuition to it, you want it to be for a very specific purpose. And there's a lot of sophistication in fine tuning. So I don't expect any of you to probably be fine tuning models anytime in the near future. But I do want you to understand this concept that the generative pre-trained transformer is very generic. It literally has probably been trained on all the high quality data on the internet that is available, including books. Anthropic, for example, it has a multi-billion-dollar lawsuit because basically they destroyed a whole bunch of books in capturing that information and using that to train their model. But so you've got this generic tool, but sometimes you don't want a generic tool. You want something that has been tuned for a specific domain. And that is the value of fine-tuning a model. I want you to know that that is possible, so that, let's say, for example, you're doing a coaching business. You want to feed it some additional information so that when you ask it a coaching question, it's going to provide a response back specifically about the frameworks that you feed it. So maybe it's Jim Rohn or Tony Robbins or some other well-known coach that you're going to get back coaching responses. So there are several different ways you can kind of fine tune a model and make sure that it's available for a very specific domain. So yeah, Mikkel?
So I had a conversation around this exact topic this week, and maybe you can explain for me, in fine-tuning a model and it being hyper-specific for the legal aspects, are we limited in deep research if we stay within that model to be more broad? That was something that was kind of pushed back to me, that doesn't make more sense to have a broader scale to get more research, or do we stay inside that model?
The short answer is it depends, and it probably would require some experimentation both ways. Now, if you have a really good set of high quality information that you can use to train the model, I'd probably would stick to that, but again, it's got to be domain specific. It has to be high quality. It has to be detailed. Like you typically have to feed it a fairly comprehensive data set in order to do that. Now, that doesn't have all the information in the internet. So if you say, like, here's like a well-accepted set of information, that would be good for fine tuning. But if you want to explore the information that is available about that particular domain, then doing something like a deep research, which will look at like current research documents, current blog posts, current YouTube videos, all that content, like it really allows you to be more current. And this is one of the challenges of large language models. They are trained up into a certain point in time, and then their training stops. So one of the value propositions of deep research is the ability to go out and get fresh and new information about a particular topic. So those are some of the trade-offs that you need to consider while you are, whether tuning makes sense or whether you want to go and do deep research on the current set of information.
Thank you.
Yep. So any other questions before I go on? Jill, I just want to pause for a second. Is this starting to make sense, the pre-reading? Am I tying that into this information in a way that makes sense?
Yeah.
Okay, excellent. Okay. So prompt principles. So obviously the heart of engaging with a large language model is a prompt. And there are lots of different ways that we can do prompts. One is called one-shot prompting, where you kind of dump everything in and you see what you can get back. The other is much more iterative, like it's few-shot prompting, or giving it examples and say, I want you to do this, and an example is this particular, maybe it might be a set of code. It might be a test script. It might be the example of a product requirement. And so you kind of, you give it those examples in order to further refine the ability to get out of the system what you were expecting. There is also something called chain of thought prompting, and I would say that that probably is a little bit outmoded. And part of the reason that it's outmoded is because in order to activate the chain of thought prompting, and it's basically what you would put into that chat window, it basically, the thinking models have assumed this functionality of the chain of thought. The number one way you would trigger that is literally by saying, think step by step. And so when you are selecting a model, if you want it to be really thoughtful, logical, and in-depth, then your model selection probably matters more than just your chain of thought. Although you can get a non-thinking model to think more like a thinking model if you include it in that prompt. And then the final version, which is the newer version, is called chain of draft. So one of the things that it acknowledges is that when you prompt a large language model, you want to give it the minimum valuable set of context in order to get the information that you want out of it. If I go and I give just a ton of information, like about a particular topic or what I want, sometimes that actually dilutes the instructions. So you want to be maybe a little bit more structured. You want to be concise. You want to think about it before. And the more you are clear and concise and give it that minimum minimum valuable set of information, you actually get a more accurate response, and it actually gives you a response back faster because it doesn't have to decode what is noise from what is actually meaningful intent. So while you are creating your prompts, one of the things that is really important is to just be aware of that. Like, rather than just throwing out everything that that is relevant, if you really want to get a high quality response, you really want to do some thinking ahead of time to make sure that you're getting back the best set of information. Okay. So I will pause here for just a minute. I would like some engagement here to get people's feedback on what are some of the things that you've noticed while you are prompting large language models that has helped you to get back a better high quality response. Yeah, Eric?
Kind of what you said earlier, like with your example of creating the image with the logo, the more specific you are, the more high quality it is, but also the interactiveness and follow-up. I've noticed that's very helpful. If there's something you don't like or you want it to tweak or you need it more succinct or put it in a different voice, it's the iterations.
Yeah. And the other thing that I would also say about that, one of the things that I have started to do was when so let's say I've got an initial prompt and I do several different variations of it in order to get exactly what I want. One of the things that I will ask the language model is, okay, with this context, and I tell it actually, first of all, this is exactly the output, or this is very close to the output that I was expecting, or the response that I was expecting. One of the things that I'll ask it is, okay, knowing that we're in a good place, how could I have prompted better to be able to more quickly arrive at this type of a response? You'd be surprised at the feedback that you get. If you would have done this, if you would have provided this, if you would have been clear on this set of instructions, we could have gotten here sooner. That's a good best practice with prompting. And if you really pay attention to the feedback that you get, you'll probably start to notice patterns, but you'll also get some ideas on how to prompt better. But one of the things that large language models are incredibly good at is basically learning, is that learning process, and take the time to synthesize that, because it really will, I believe, make a difference. Okay. Any other comments on what you have learned in prompting that has helped you to get better responses?
Jason,
yeah.
just really quickly, I think for me specifically is essentially defining what approach I want to be, like what expert am I when asking a question, right? Is it going to be me, myself, and I, or am I looking for a different perspective that's a different type of expert in a different industry? So I think that for me has been able to kind of broaden responses and results in fields and areas that I may not have as much knowledge.
Yeah, I think that's a great one. Like identifying your role and then also identifying how you want the model to respond to you. So like saying, hey, you're an expert in this particular field. And it's actually interesting if you say you're a 5-year expert, a 10-year expert, or a 20-year expert, that can change what you get out of the large language model. Another thing that you can also do is to tell it, respond to me like I'm a 5th grader, or respond to me like I'm a 10th grader, or respond to me like I'm a PhD student. Like each one of those, like by telling it how you would like it to respond, it radically changes the output. So like the other day, I put in a prompt, and it was actually for a statement of work for a client. And I was reading through it. I'm like, this is just, it's wordy. It's not clear. I'm a little confused. And so just as an exercise, I told it to respond like I'm a 10th grader. So like not infantile, but, like make it pretty simple and easy to understand. And what I got back, like I was really happy with. And I actually gave it to one of my colleagues, and he says, like, this is brilliant. He's like, because he originally drafted it, and I was kind of curious how he would feel about this like major revision. But he said, this encapsulates much better what I was intending. It eliminated a lot of noise, and it made it very clear what the client expectations were from the engagement. So all those are things that you can do in order to alter that feedback to make sure that you're getting exactly the response that you hope. Any other comments before we continue on? Okay. So the next item, it kind of ties back to maybe like job security a little bit and career evolution, but there's been a fair amount of research, and basically the research indicates that 50% of a knowledge worker's day doesn't really move the needle on achieving their objectives, and only about 42% is actually engaged in moving the needle forward. So producing something, building something, engineering something, designing something. And so this is one of the things that artificial intelligence, I think, can really help people to be more efficient in their work effort, to reduce that administrative drag. Now, many of you probably have access to Copilot. You probably use Outlook. You probably have access to Copilot. And you've probably done something like summarize this thread. You get this email thread of 20 emails. It's like, I don't want to read through all this. And you ask for a summary, or ask for what are the action items that are coming out of this? Who's responsible? And is there a due date on them? Like, it's very helpful at not having to read through, decode, remember all this stuff, when in reality, you probably need just a few pieces of information to, one, understand the content, and second of all, to understand the action items that come out of it. So there's a lot that we can talk about as far as reducing the administrative drag, but I think it's one of the areas that's easy to do that administrative reduction, to increase your productivity and effectiveness, and three, just to not have to do things that you don't like to do. And I'll give you an example of this. So the bane of a consultant's existence is time tracking. And we all have to do it, and we all hate doing it, or an expense report. So what I do at the end of the week is I try and make sure when I schedule a meeting, I either color code it or I give it a prefix for the project that I'm working on. The end of the week, typically just take a screenshot of my calendar and say, categorize it, give me a breakdown of how much time I spent on each project by day. And basically it outputs that as a table. It's probably 80 to 90% correct. Make some minor modifications, but it has made tracking my time just so much easier by using these models in order to automate some of this very, like important, but at the end of the day, not very meaningful pieces of work. All right. So I've talked a lot about theory. Now what we want to do is we want to jump over into large language models and how that actually works. So here's what I'm going to do. If you can still see my screen, this is an example of a large language model that I use called Gemini. And we only have a few minutes left, but I wanted to give you a brief orientation that hopefully will tie back to some of the things that we've talked about. Now, if I type in a prompt right here, so I say, what color is the sky? What it's going to do is that is going to be sent to the large language model. I'm going to get back effectively something that's very simple. Short answer is blue, but the Y is actually pretty cool. So I'm just relying on that parametric knowledge that is within the large language model. And in this case, not terribly complex. It even gave me some, bonus information. But let's say, for example, I wanted to do some deep research on that. So one of the things that we've talked about is a RAG repository. So deep research, just think about it like a web search enabled RAG repository, because what it does is it goes out, it does a search, it finds information that is relevant, it tries to filter out the noise, and it takes all those snippets of information and it puts those into the large language model, and that is what I get back. So let's say, for example, give me an administrative guide for Sprout social software. And it will probably tell me that I have to start a new chat, and that's okay. Yep. So I say, go do deep research. And I can also select, like, do I want it fast? Do I want it to think about it? Or do I want it to really think about it? So just for these purposes, I'm going to select fast, just so that you can see this. So I told it to show me the information. And so it asks me, do I approve the research plan? Which I, said yes. And then what it does is it shows me the thinking. So it shows me that process. I'm going out to, this is what I tend to do. I want to establish an administrative framework. I want mapping governance and security. I want to investigate workflow and financial information. And so using Google search, it goes out and it finds all these resources that are relevant. So this will probably churn for at least 5 minutes. And typically it gets to a point where it says, I'm saturated. I'm not learning anything new. I think I understand the concepts. Now I'm going to give you an output. So this is like super sophisticated in being able to do that research. But again, at the end of the day, this is nothing more than really a RAG repository. So Eric had mentioned images and videos, so I can create images and videos. Those are kind of ubiquitously available on all the large language model platforms. Canvas, which is basically, I want to create a document or a PowerPoint, and I want to dynamically interact with the information. And then the guided learning is much more of like a study guide, for example. So that at a 50,000 foot level is, hopefully ties together some of the concepts that we have into what you see within this large language model interface. And then the final thing that I think I'd mentioned before, but I'll just highlight again, you're picking different models. If you want something quick, fast, if you wanted to do that thinking, that think step by step, in order to be more thoughtful and comprehensive, and then that pro version like really uses all the artificial intelligence capacity in order to really try to arrive at your most difficult problems. So between these things, which are called tools, and your model selection, you should get much better at getting the responses back that you hope and expect. So I just pause there we only have a few more minutes. If anybody has any questions, I'm happy to field those. Otherwise, we'll plan on seeing you next week at the same time.